Okay. Did all of you get a chance to do the learning exercise yesterday? Can you show me a raise of hands? Boys and girls, raise of hands. Okay, okay, good, good. How about you, Nagendra? Jagdish, good.
Hello.
Yes, Nagendra.
Sir, yesterday I was in traveling, sir. That's why I didn't attend the class. Today I
Okay.
will.
Did you see the video that was uploaded in YouTube and had given access?
But I'm not getting that access.
Uh-huh.
First,
Uh,
try to open that video, but I'm not getting that access to open that video.
I had whatever email ID you had given at the time of registration,
Okay.
that is the one I had. So you have to log into YouTube using that Gmail account. Only then you will get access. Okay?
Oh, sure. Okay, okay. I'll do
Okay.
that.
Just try it once.
Okay.
Okay. And still, if you are not getting, you let me know. I will, try to troubleshoot that.
Sure, sir. Thank you.
Okay. All right. Anand, yes, you had a question?
No, sir, just raise the hand.
Okay. Okay. All right. So, boys and girls, any questions from yesterday? Anything that you didn't understand? Anything that you felt was very complex? No? Okay. We are still, scratching the surface. We have not gotten into the complex things yet. And starting today, we are getting into certain things that require your complete attention. Okay. So please focus for the next 1 hour or so and listen very carefully and attentively. Any area, any word, any terminology, if you feel that you're unable to understand, please let me know. I will repeat and I will try to make you understand more clearly. Okay, so let me share my screen and we'll get started. I hope you are able to see my screen. Yes? No?
Yes, sir.
Okay, thank you. All right, so we learned all of this yesterday and we did a knowledge check. Now we are going to talk about different kinds of storage media. Okay. Now, let me start with my own example. Um, when I was in school, right, I started learning computers from the age when I was in standard four. Okay. That time, many of you were probably not even born. Uh, the first kind of storage that we actually saw was floppy disk. Okay. What is happening with this? 1 second. Okay. The first kind of storage device that we saw was a floppy disk. That too, it was 5.14 inch in diameter, big floppy disk. And it could store hardly a few MBs of data, 100 MB, 200 MB, that much. Then within a couple of years came smaller floppy disks, like 2.5 inch floppy drives. Okay, we thought that was revolutionary. Okay, that could store a little bit more data even though the size was smaller. I said, wow, this is great. But then as we moved forward in life, we saw bigger computers, bigger machines having something called as hard disks. Okay. And then we understood, oh, what we were doing with floppy disks was nothing. And it is the era of hard disks. And that is what we are going to learn today. We are going to learn what are the different kinds of storage media available that is used in storage systems. Okay. And uh, how exactly do they get connected to the workload in order to serve data? How exactly do they store data also? We are going to learn all of this. Okay. Now, before we start, imagine this lady with whom you see on the screen to be a potential customer. Okay. And this potential customer is running a company which is developing, let's say, an OTT platform like Netflix. And they are going to stream high quality videos to millions of users across the world, right? And their requirement is we need fast data access capabilities that guarantee our subscribers the video without any data loss or delays. Okay. Now, yesterday we learned about structured data and unstructured data, right? So, what kind of data category do you think this falls in? Is it structured data or is it unstructured data?
Unstructured, sir.
Unstructured. Why do you say it is unstructured?
Oh, because it is a media, sir. Media means videos and all, sir.
Correct, correct. Any other guesses? Structured or unstructured? But one thing we learned about unstructured data is it's okay if there is any delay, right? That is what we learned yesterday. But this lady is talking a different thing, right? This lady is saying it is unstructured data, that means it's videos, but they don't want any delays. Okay, so this is the new expectation of unstructured data. Okay, it is unstructured in nature. It is all stored as files and objects, not in databases, not in any predefined formats. Okay, but the expectation is that there will be no delay in accessing that content. Okay, so we need to understand what kind of a storage system or what kind of storage systems can actually help in serving this kind of a requirement. Okay. So here is where we introduce different kinds of storage media. When we say storage media, it is nothing but the actual, disks or drives on which the content is stored. Okay. So here today in the industry, we have these four categories of storage media. Okay. So I will start from bottom to top. Magnetic tape drive. You remember yesterday when we were doing the class, we spoke about a particular example of audio cassettes, right? So when there were no smartphones, all the popular songs, we used to go to this cassette shop and we used to give a list of songs. That guy used to record those songs onto a cassette player. So that's a perfect example of how data gets stored on a magnetic tape drive. So what happens is that reel of the cassette, even in the case of a video cassette, okay, that is coated by a magnetic material, okay, which is which can be charged when it is going under a electromagnetic device. Okay, so all the particles on that magnetic tape drive can be aligned to represent a 0 or 1, like binary, and a combination of 0 and 1s will give you the information or data that you want. Okay, now even today many data centers, including data centers for banks, data centers for large healthcare companies, insurance companies, telecom companies, till today they use magnetic tape drives for some purpose. Okay, what is that purpose we will see later, but you can assume that they are still in use, but larger and denser ones. Okay, like earlier, magnetic tape drives could store maybe 1 TB, 2 TB kind of data, but today there are magnetic tape drives that can store multiple terabytes, like 30 terabyte, 60 terabyte, 100 terabytes also. Okay, without increase in physical size. Okay, without increase in physical size, just becoming denser and denser in terms of how data is stored on that storage medium. Okay. Then the next category is called optical disk drives. Optical disk drives are nothing but the CD drives. Okay. The Blu-ray discs or the DVDs. Okay. And they can store, as you know, a Blu-ray disc can store 10 GB. Okay. There are high density Blu-rays that can store more, but these are not used today. Okay, you can say they were a technology that came in the middle, in the interim between magnetic media and solid state drives. Okay, so but it's not used today, so we are not going to focus much on optical disk drives, but just to relate what exactly it is nothing but the DVDs, the Blu-ray discs that we see, where laser light is used to store and read information on a photosensitive material. Okay, photosensitive material. That material reacts to light, and hence laser light is used to read and write data from a optical disk drive. Okay, but it is slow, it is erroneous, there is a lot of corruption that happens, so people don't use it for very critical information storage. Then I will talk about hard disk drive before going into solid state drive. Hard disk drives are nothing but magnetic platters condensed and stored in a very small physical form, which can read and write data in relatively higher performance than magnetic tape drives. Okay, actually much more, and they can also store a lot more data. Okay, but of course, there are many advantages of hard disk drives. There are many disadvantages also. So we will see what they are in the subsequent slides. And then comes your solid state drive. In solid state drive, there is no moving part. Okay, it's everything as small transistors. We learned yesterday, right? Every electrical and electronic component, if it has to store some information, they will use transistors. If the transistor has no charge, it is considered as zero. If the transistor is holding some charge, it is considered as one. Okay, and there are high density solid state drives where, what depending upon the level of charge, like if the charge is 0.5 volts, then that means something. If the charge is 1 volt, then it is something else. So that level of transistor technology has also come, where a single transistor can hold different levels of charges, and based on that, data is inferred. Okay, no charge means of course zero, but um, more complex algorithms, especially in quantum computing. Okay, this is used in order to hold different charges on the same transistor, and hence the density of the solid state drive increased drastically. Okay, so one good example is the SD card that we were talking yesterday, which we put in our phones, right? That's a perfect example of I would say a single cell solid state drive. Now, what is single cell, what is multi-cell, we will talk later. Okay, but that's a perfect example of a solid state drive. There is no moving part. All the data is stored in terms of transistors. Okay, so let's move forward. Let us learn about what's a hard disk drive. So I'm sure many of you wouldn't have opened an hard disk of your laptop or desktop and seen what is there inside. Okay, so this is what is there inside. Okay, this white shiny surface that you see, That's called a platter. Okay. So this platter is coated both on the top and bottom with electromagnetic component or electromagnetic coating, I would say. Okay. So that when a magnetic needle comes near it, that needle can be used to write some information onto that electromagnetic surface or read some information from that electromagnetic surface. Okay. And where is that needle? That needle is positioned at the tip of this arm that you see coming from the left hand side. That's called an actuator arm. Okay. And this middle uh, fat drum or a cylinder that you see, that is the one that holds these magnetic platters inside a hard disk and allows the platter to rotate at certain speed. Okay. And depending upon the speed at which the platter rotates, the performance of the hard disk can be arrived at, or you can understand at what level it will perform once we know the RPM, okay, rotations per minute of that particular hard disk. Any questions? So let me show you, or let me on my camera. Okay. So you saw these hard disks, right? So the hard disk will actually be very, very, small. It will be, uh, just the size of probably this power bank. Okay. But when you open the hard disk, right, inside the hard disk is where all this mechanism will be there. Okay. How the hard disk will get connected, we'll talk later. Okay. But first understand what's inside a hard disk because this is critical. Okay. And there is not a single platter inside. Okay. There is multiple, magnetic platters inside in very close proximity. Okay. Just one after the other. There's just millimeters gap between one platter and another platter. So it's not a single platter that is there in the hard disk. Okay. There are multiple platters that are there in the hard disk. Okay. Between each platter, the first platter to second to third to fourth to fifth, maximum there'll be 4 or 5 platters. Okay. Between each platter, there is just, millimeters of gap. Okay. And all these platters are placed concentrically one below the other, one below the other, like this inside a hard disk, right? And the actuator arm, okay, the arm that we saw on tip where is there is a needle. You can imagine in olden movies there used to be this gramophone record, right? These film stars used to place a big, magnetic, record, and then they used to put a small needle to on top of it, and as the record revolves, that needle would, read the information and play the song, right? Exactly the same mechanism is used inside the hard disk, nothing different. Okay. But the only difference is instead of one gramophone record and one needle, we have multiple gramophone records and multiple needles. So the actuator arm is not just one arm like this. Okay. It's a multiple arms like this, multiple arms. So in between the two arms, okay, the platter is going to be placed like this. In between two arms, the platters are going to be placed. And the actuator arm can only rotate so much, like 15 degrees, so much only. Okay. So, but the hard disk here will be spinning very fast. Okay. In between. And depending upon, where the data has to be written, the actuator arm will move. Okay. And wherever it stops, the needle at the tip of the actuator arm will allow to do read and write operation on that portion of the hard disk. Okay. So Let me see if I can find a animation for you on this. Just give me a moment. In the meanwhile, if anyone has any questions, please feel free to ask. No questions? Okay. Right. I got a video. Let me play that for you. Just a minute. Let me share my screen. Yeah. Are you able to see my screen?
Yes,
Okay.
sir.
Now just pay attention to this video. So this guy is talking about data storage and all of this. Yeah. So this is a hard disk, what I was talking about. And you see there are multiple platters inside, okay, like this. And each platter is connected to an actuator arm. And see, the actuator arm has needle on top and bottom also. Just move a little bit back. Yeah. See, this is what an actuator arm has. So the tip of the arm has that magnetic needle, and the platter will revolve or rotate inside the small gap that you see between the actuator arm. And why? To so that both the top surface and the bottom surface of the platter can be used, so that the density of data that you can store in a single hard disk can be increased. Okay, that is the reason why inside a hard disk you will see 3 to 4, as I said earlier, or 4 to 5 platters. Each platter will rotate, and while they are rotating, these actuator arms will move and they will magnetize or demagnetize a portion of the hard disk using the needle, and that will be the data that is written to it. Okay, like this. Okay, so this is a very good example. So each area that it magnetizes is a bit, and this is the symbol of magnetism, right? Alignment in one direction or alignment in another direction. So if it is aligning in one direction, it is a 0. If it is aligning in another direction, it is a 1. Okay, so it's very simple mechanism, but the way it is implemented is pretty complex. Okay, and it involves a lot of precision. So the same needle which is used to write, it is not the same needle which is used to read. Okay, there is a separate magnetic sensor next to the needle which allows to read the information that has been written on that magnetic platter. Okay, so this is how an hard disk a hard disk works. And yesterday we learnt about binary code and ASCII code, right? So this entire zeros and ones that are written onto a hard disk, after being read, okay, they get converted into ASCII, and the processors and the memory inside the CPU, they are going to make sense out of this information. So this is an example of a hard disk which can store 600 GBs. Okay, but earlier the amount of storage that we can have in a hard disk was very very small. Okay, in earlier decades, in 1950s and 1960s, it was measured only in MBs. Okay, and as and when this magnetic material technology kept on improving, the density in which we could write to a hard disk kept on increasing. Okay, so this is a very good graphical representation of how a hard disk works. Okay, now moving forward a little, So maximum information density is the amount of data that you can actually write on a hard disk in a given square inch. Okay. So as the hard disks got better and better, the amount of information that we could store got increased from GBs to now in terabytes. Okay. So today we have hard disk which can even store 300 terabytes in a single disk. Okay. So how instead of using only magnet, they are also using heat. Okay, a little amount of heat to write and read data from the hard disk. So yes, 20 terabytes, 30 terabytes, and all that information is nothing but the songs and content, our workload that we were speaking about yesterday. All that is stored in a hard disk. Okay. Any questions about a hard disk? Maybe when we meet, I will show you exactly how it looks. You can touch and feel it. I will allow you to open a hard disk and see what's inside. But one thing you can be rest assured, once you open a hard disk, you cannot reuse it because they are vacuum sealed. Okay. So once that vacuum seal is gone, it's very difficult to make that hard disk work again. Okay. So it may not work. So moving forward, yeah, we come to solid state. So yesterday, we learned that SD cards are a perfect example of solid state drives. So why this solid state, drive and what exactly it is, I will tell you. Now, in our college, you would have learnt that there are different kinds of RAM and ROM available, right? RAM stands for random access memory. ROM stands for read-only memory, correct? So what exactly is going on in a RAM or a ROM? It is nothing but those transistors and chips that I spoke about yesterday. Okay, so these transistors and chips are placed on a circuit board. Okay, this green color circuit board that you may have seen and used during your college experiments. Okay, and whenever power is supplied to this particular circuit board, the transistors inside or that are placed on that circuit board get the ability to charge or discharge. Okay, if it is charged, it's a separate bit. If it is discharged, it's a another kind of a bit. But we know that if it is ROM, it is if it is RAM, RAM is a volatile memory, right? Volatile memory means what? When there is no power, you cannot store anything on that particular device. It is very similar to the memory in your phone, the memory in your laptop, okay, the memory in any particular computer. When you power off your phone, when you power off your laptop, whatever is there in the RAM gets lost. Okay, you cannot recover it back, right? But this is contradicting to what we learned yesterday about storage systems, right? We learned yesterday about storage systems that storage systems have to store the data permanently, even if there is no power, right? Which means RAM technology cannot be used to build solid state drive. You have to use something else. What is that something else? ROM, read only memory. Okay, so whatever technology was used to build ROM, that is the technology that is used to bring or to build solid state drives or solid state disks. Okay, but ROM is read only memory. That means once you write anything to a ROM, you cannot change it. But we have also studied in our engineering and degree courses that there are different kinds of ROMs available, right? So there is something called as EEPROM. So in ROM, there are different categories, right? You have normal ROM, then you have PROM, PROM, programmable read-only access memory, read-only memory. Then you have EEPROM. EEPROM means electrically programmable read-only memory. Okay. And then you have the ultimate category of ROMs, which is called as EEPROM, electrically erasable and programmable read-only memory. Okay, which means not only can you read data, you can also erase that data and rewrite new data in an EEPROM. Okay, so that technology, EEPROM technology that we had learned during our engineering and college and degree, that is the technology that is used in solid state drives. But of course, very condensed and very high performance. Okay, so this is how the knowledge that you had learned in college can get applied. So the SD cards in your phone, they are all solid state drives, nothing but EEPROMs. The internal memory of your phone, where you're storing information permanently, even if your phone is switched off or your laptop is switched off, where the data gets stored, it gets stored in a solid state drive, which is nothing but an EEPROM. Okay. Some advantages of EEPROMs are, because there are no moving parts, there is no vibration. Number one. Because there are no moving parts, all transactions happen at the speed of current, or the speed at which electrons get transferred on that copper or silicon media, right? So extremely fast. Nothing in the world can compare to the performance of a solid state drive versus a magnetic drive, a optical drive, or a hard disk drive. Okay, extremely fast. Third, there is not much of heat that is getting generated through a solid state drive, because there are less number of moving parts. You don't need an electric motor, you don't need an actuator arm to move, you don't need any of those things, right? And hence the power consumption required to use a solid state drive is also lesser. Okay, heat is lesser, power is lesser, it is much faster. Okay, it can store huge amounts of information. Okay, but it took many years for the industry to build reliable enterprise class and high density solid state drives. Okay, it's only in the last, I would say, 7 to 10 years is when this technology got really advanced very quickly. And now we are seeing large scale deployments of solid state drive. But even till today, hard disk drives are also used. Even till today, magnetic tape drives are also used. Okay, where they are used, how they are used, why they are used, we will see. Okay, any questions on solid state drives? And have you understood clearly the difference between a hard disk drive and a solid state drive? Okay, no questions? Moving forward. So this is an optical drive. We already learned about this. So it uses a photo sensitive material so that laser light can be used to read and write data. All our DVD CDs, they all come under this category. It says used for data backups and data archives, but not anymore. Okay, people use tape drives. Yeah, these are the tape drives that are used in data centers. Okay, not the audio and video cassettes that we knew. Okay, these are the tape drives that are used. And you remember yesterday I was talking about the BSNL example. So the BSNL, tape drive or tape library, it is called. Okay, it is so big that 10 humans, okay, 10 full grown humans can stand inside this tape library. Yes, okay, I'm not kidding, I'm not joking. It's huge, it's humongous. Okay, it's probably the size of one big hall. Okay, where thousands of tapes are there, and there are each tape is, as you can see in the picture, is labeled with a barcode, unique barcode, and that unique barcode is the identification of that tape. So there will be robotic arms which read the barcode and understand which tape to be put in the tape drive. So what is a tape drive? A tape drive is like the cassette reader. Okay. So once the tape is mounted or put inside the tape drive, it can start reading and writing from and to the tape drive. Okay. And all this is handled by robotic arms. There is no manual intervention required. And that's how tape libraries are built. Okay. So whenever we are visiting a data center, I will try to show you smaller tape drives are also available. Larger tape drives are also available. Whatever we can, we will try to see. Okay. These tape drives are extremely low cost. Okay, and hence they are used for something called as archives. Okay. Now, what's an archive? An archive is nothing but a collection, a library. Okay. uh, all our governments put some regulations on these telecom companies, healthcare companies, banks, that you should keep the data available for reading and writing for 7 years, 10 years, 14 years. Okay. Now, government has given this regulation, but they are not giving the money, right, to implement these kind of technologies. So, what is the way the companies have found is whatever is the latest data, maybe your last 1 year data, that is stored in hard disk and solid state drives because they are very, very costly. Okay. But this long term storage, okay, which has to be retained for like 7 years, 10 years, 14 years, those they write it onto tapes and they put it in something called as tape vaults or tape archives, and they make a note of these barcodes, that which barcode tape drive has got which information, which year's information, which month's information. And that is how whenever any auditor comes from the government or from an external third party, they will retrieve the tape from the vault, put it in the tape drive, and read and write that information. That's how these large companies are currently handling their data requirements. Okay. Any questions on the types of storage media, whatever we have learned till now? Okay. One small knowledge check. Please read the question on your screen carefully. A premier streaming network like an OTT platform requires high quality videos to be streamed to a million plus subscribers across the world. Is the same question that the lady was asking us in the beginning. They need fast data access capabilities that guarantee the subscriber can view videos without loss or delays. So at the back end, what kind of storage media is most suitable? Okay. Is it a hard disk drive? Is it a magnetic tape drive? Is it a solid state drive? Or is it an optical disk drive? Please put your answers in the chat. SSD. Okay. Jagdish. Gopi also says SSDs. Jagdish also says SSDs. Renu also says SSDs. Shivani also says SSDs. Well, uh, let me give you a practical answer. Yeah, theoretically, you're right. Theoretically, all of you are right. Okay, there is no denying the fact. Okay, but practically, it is, I would say, partially right. Though this guy will say that you know you can do that. You can use solid state drives, but the problem is cost. If you have to store petabytes of data on solid state drives, it is going to be extremely, extremely expensive. Okay. But the problem is not all customers are ready to pay that kind of money to store data for long term. Okay. They always want a cost optimal solution. They don't want very expensive solutions, especially, people in countries like the Indian subcontinent, the Asian countries, then South American countries, African countries. Okay. The people who are running data centers in those countries, they do not have the capability to spend so much. Okay. And hence, cost becomes a big factor. And that is the reason why they use a combination of SSDs and hard disks to achieve whatever was this requirement that they were talking about. Okay. This requirement. Okay. How? So we will later introduce a concept called storage tiering. Okay. And when we are talking about that concept, I will explain to you exactly how such a solution is built. But just to give you a high level idea right now, okay, the solid state drive will be used to store the latest information, and hence only 10% of the capacity will be stored on solid state drive, and the remaining 90% will be stored on hard disk drives, which are much cheaper. Yes, slower, but much cheaper. Okay. And this SSD drives become like the caching layer or the intermediate layer for accessing the data inside the hard disk drives also. So even though the hard disk drives are also connected, even though the solid state drives are also connected to the same system, the data inside the hard disk drives, in order to read, you have to go through the solid disk drive layer. So in that way, what happens that you're getting fast access to the latest data, but at the same time, you're not spending a lot of money to store the huge amount of data. Why so? Okay. And why this works and why this is acceptable is because, for example, all of you watch Netflix videos, right? After you have watched a certain next Netflix video, will you go and rewatch it again immediately? Very rarely, right? Which means only the latest content or the latest video is something you will watch, and then very likely you will forget about it. Okay. But the Netflix company has to keep that video, right, in its platform, because the content maker has paid them to host that video on their platform. Whether you as an end user watch it or don't watch it, it doesn't matter. Netflix has to keep it. So how Netflix has to keep it for a long period of time, but at the same time not spend so much, is by using this storage tiering technology. Okay. The latest data will be there in SSDs. It will only be 10% of the complete capacity, and the remaining 90% will actually be stored in high density hard disks. Okay. So that it is online, it is relatively fast, not as fast as SSDs. And whenever a user wants to see that old video which is actually stored in the hard disk, that data will get copied on automatically to the SSD layer, and from there it will be served to the workload, which is nothing but the app or the end user. Clear? So though the answer to the previous question, all of you had given absolutely right, but that's not practically what happens. Practically, people use something called as storage tiering technology, where in the same storage system, multiple tiers or multiple levels of storages or multiple sections of storages are created. The highest performing section or the highest performing tier will be with SSDs, and then the lower performing tiers or sections will be with hard disk drives. The SSDs can be used as a caching layer so that all the read and write operations to the entire storage system, including the hard disk drives, will go through the SSD drives. Okay. And that's how they meet the capacity requirement, the performance requirement, and also at an optimal cost. Okay. What is storage tiering? We will learn later. All right. And we will go depths into it. All right. Now is the time we go a little bit depth into the functioning of an SSD. How exactly an SSD works, how it gets connected, and how data is stored in it. So, first thing you need to understand is every hard disk or every storage media will have something called as an interface. What's an interface? An interface is like a port, okay? Like your charging port, right? The charging port is a C-type connector in most of your phones, right? But that same port is used for data transfer also when you connect it to a USB, right? So that becomes an USB interface between the phone and your laptop. So that's an interface to transfer data from one medium to another medium, right? So in this diagram, this top yellow portion that you see on the SSD, that's called an interface. So that's the port using which this storage medium, which is there on the circuit board, is connected to a larger system, okay, like a storage system. And it is through this port, it is through this interface that all the read and write operations to this storage medium is happening. Okay. Now, there are many kinds of interfaces that are available out there. All right. But we need to understand certain terminology here. Okay. The first terminology that you'll have to understand is called as SCSI. Let me do this. Okay, 1 second. All of you are hopefully seeing my screen. So it's the term that you need to understand is called SCSI. It is pronounced as SCSI, and SCSI stands for Serial Controller, sorry, Standard Controller Serial Interface. Okay, Standard Controller Serial Interface. It's a serial connection basically between the hard disk drive and the larger system. All right. So in our course module, we are seeing these protocols. Okay. Now, what are these protocols? First of all, what is a protocol? Can anyone give me a brief answer? What do you mean by a protocol?
A set of rules.
Yes, correct. Protocol is nothing but a set of rules. And we know this common protocol called TCP/IP, right? Transmission Control Protocol and Internet Protocol. Now, this is a protocol used in networking, which we will learn later, which you also have learned. Uh, 7 layers, okay? Layer 0 to layer 7, okay? But in this case, SAS, okay, is called Serial Attached SCSI, okay? And we just now saw what SCSI means, Serial Attached SCSI. Then we have SATA. SATA is Serial Advanced Technology Attachment. Okay, this is another way. And then FCP. FCP stands for Fiber Channel Protocol. Okay, these are nothing but various rules that have been written by the industry which will define how a hard disk or an SSD should be read and written to, because the manufacturer of the storage system is separate, the manufacturer of these SSDs and hard disks are separate. Okay. And in order to have consistent interoperability and compatibility between systems, protocols had to be developed so that most kinds of SSDs and hard disks can be put into most kind of storage systems. Okay. Let me go back to our phone example. Let us say you buy an SD card from Amazon or Zepto or anything, right? You would expect that SD card to work in any phone, right? Whether it is Oppo, Redmi, okay, whether it is OnePlus, Samsung, you would expect it to work on any phone. How is that possible? Because the manufacturer of the SD card, let's say, is Samsung or SanDisk or Western Digital or these companies. The phone manufacturers are separate, right? They are these Redmi, Oppo, Vivo, then Samsung again, then OnePlus, Google, Nokia, all these, right? So, how will, for the sake of end customer and user like us, how will the industry make sure that any kind of SD card should be compatible with any kind of phone? That's because of these protocols. Okay. So, whenever an SD card is being manufactured, whenever a solid state drive is being manufactured, apart from the storage mechanism that goes onto this circuit board, there is some standards and protocols that the manufacturer has to maintain or for the interface also, so that the data that is s- getting stored onto that solid state drive and the data that is getting read from it can be done across storage systems, okay, so that it is compatible and interoperable. Similarly, on the in the case of hard disks also, it's the same thing. We have seen the platters, the magnetic platters, we have seen the actuator arms, but there's also one more component in hard disk called as the interface, and there also the interface serves the same purpose, which is when the hard disk is getting connected to a larger system, it is through the interface that the read and write operations will happen into and from the hard disk. So all you people are clear what exactly is an interface? Any questions? Okay, I was just trying to find whether I have some interface to show you in my home lab here, but probably I'll show it to you tomorrow. Okay. All right. If there are no questions, we move forward. So inside a hard solid state drive, primarily apart from the interface, there will be these two additional components. This is called the memory unit and the controller unit. Okay. So let us talk about the memory unit. So this is the most important one because this is where the data is stored. Okay. Those transistors that I was talking to you about, exactly these are the high density transistors. Okay. If there is charge in the transistor, it is some bit. If there is no charge, then it is zero, something like that. Okay. The terminology that is used in the industry, okay, is called flash. Why it is called flashing or why it is called flash, I'll tell you. You remember a little while back, we were talking about different kinds of ROMs and PROMs, right? And we understood that an SSD is nothing but an EEPROM, electronically erasable and programmable read-only memory, EEPROM. Okay. And that process of electronically erasing the data that was previously stored in the solid state drive, okay, and so that we can rewrite something on it. That process is called as flashing. Okay. So people say, oh, have you flashed the drive? So no, when you are talking in terms of hard disks, you will say format. Okay. But in terms of SSDs, you will internally the term flashing is used. Okay. In electronics industry, hence the name flash drive. Okay. So you can see here there are two types of flash memories available, NAND and NOR. Okay, you would have heard these when we were learning in your engineering and degree, NAND gates, NOR gates. Okay, exactly that same technology, but in very high density. Okay, is being implemented inside the solid state drives. These are nothing but those transistors and gates which can hold charges. And depending upon the use case and depending upon the manufacturer, a NAND gate or an OR gate is used in order to store the data in the solid state drive. Okay. The next uh, component is the controller unit. Okay. This controller unit is like the mini brain of a single SSD or a single flash drive. Okay. Why this brain is required? Okay, I will tell you. See, let us imagine a scenario where you have 10 SSDs, okay, which are connected to each other, let us say on a circuit board or in a serial fashion. Obviously, each SSD will have its own unique identity. And let us say the capacity of each SSD is 256 GB. Just taking one small example. When you have connected all these 256 GB SSDs together, what is the total amount of space you are supposed to get? 256 into 10. So close to about 2.5 terabytes. Correct? Approximately. Obviously, we don't get that much. There is some other components that get added. We'll talk about it later. But effectively, some 2 terabytes you should get. But now, when you're writing, let us say a 2 terabyte data onto this new kind of SSD where you have put 10 SD cards on it, each of 256 GB, how will you know which portion of that 2 terabyte is stored in which SSD and exactly at what time? That is the job or role of the controller here. Okay, it's a very small, I would say, uh, controller, very small chip, actually, pre-programmed chip programmed by the manufacturer in the factory itself. We don't have to do anything. Okay. And that program and those algorithms inside the chip have been optimized to effectively write data across multiple flash memory chips inside that SSD or inside that solid state drive and flash drive. Okay. And they have also tweaked the algorithms to increase the lifespan of these solid state drives, because any electrical and electronic component undergoes a wear and tear, right? The more you use it, the life of that particular component starts coming down. Okay, which means there is an expiry date. There is an expiry date to everything. In order to enhance the expiry date, if you do the read and write operations in an optimal way, you can increase the lifespan of these small electrical components or electronic components. Okay. And that also is an additional job of the controller. Okay. So let me repeat what a controller does in very short, simple terms. Once the solid state drive or the flash drive is connected using the interface to a larger storage system, the controller chip, which is a pre-programmed in factory chip that controls how data should be written across the multiple flash transistors, NAND gates or NOR gates inside the solid state drive. Okay. And that control of read and write operation is there with the controller. This is the job of the controller. Any questions? Any doubts? Is it getting too complicated? No? Okay, comfortable? Let's move ahead. Okay. Now these are the benefits and comparison between SSDs and HDDs. Okay. Now one learning exercise for today, just like yesterday. Okay. Try to find the top 10 manufacturers of SSDs and top 10 manufacturers of HDDs in this world. Okay. And if possible, identify certain model numbers and download the specification sheets of each of those SSDs or hard disk models. Some names I've already taken. Okay. They are there in the industry who are developing and manufacturing these enterprise class, reliable, cost effective SSDs and HDDs. Okay. So this is one learning task for today. Identify top 10 SSD providers in the world and examples of three models with their respective specification sheets. Similarly, identify top 10 HDD manufacturers, hard disk manufacturers in the world. Identify three models and download their specification sheets. Okay, that's the learning exercise for today. Now, knowledge check. Please read the question properly. Very simple. You have to do match the following. Okay. So very simple. We have learned this. So what uses all flash memory? SSD. What kind of storage media stores data on circular disk coated with magnetic material? It is HDD. Okay. What uses laser light to read and write data? It is optical disk drive. And what supports only sequential read and write operations? That's magnetic tape. Okay. Any questions? Okay. So here is another exercise. The company wants high performance all flash storage system. Okay. To meet the demands of their employees because this system is used for a data sharing platform. So now we get into a little bit more details about how a storage system looks like, how these hard disks are placed, and all that. So you see this video that is running. Every hard disk will have this LED that is glowing on the top. So what you're seeing here is a hard disk or an SSD. Okay. So whenever any read or write operation is happening on a hard disk, this green LED will glow. So the reason why you're seeing they are like flashing, glow worms, is because continuously read and write operations are happening to hard disks and SSDs all the time. Okay. 24/7. And that's why you keep, seeing these lights and LEDs keep on flashing. Okay. Now, where are they connected? Where are they getting their power from? Okay. So they, yeah, if you can see clearly or just observe properly, these are all placed inside a chassis. Okay. It's like a shelf. And this shelf is actually placed inside something called as a data center rack. Okay. Not the normal racks where we put our clothes. Okay. These are specialized racks meant for data center equipment. Okay. There are some standard dimensions. Now, these shelves are also designed as per those dimensions. The shelf will have connectivity to power, it will have the cooling fans, okay, it will have the controller units, it will have the interfaces to connect these disk drives to a larger system. All those things the shelf will have. And the shelf will also have the ports and interfaces to connect these individual SSDs and hard disks. Okay. So just to give you an analogy, in a laptop, there is place to connect only one hard disk, HDD or SSD. Okay. But in a data center, these shelves will have the provision to simultaneously connect hundreds and sometimes thousands of hard disks together in one system. Okay. That's how petabytes and petabytes of data can be stored in data centers. Okay. Ultimately, these are all individual hard disks only, but they are designed to work together. They are designed in such a way that data gets written to them simultaneously across. Okay. And when data is getting read also, it is being read simultaneously from across these hard disks. Okay. And that's the job of a storage system. And you will see in this same video, the hard disks sometimes are placed vertically like this. Okay. But you see on top, some are placed horizontally also. Okay. These horizontal ones are the older technology. Okay. The HDDs of older technology, earlier they were used to place like this horizontally. But nowadays, many are being placed vertically. And very recently, we have seen even they are like placed in bays inside a shelf. So we will see that later. Okay. So here in the slide, you're seeing that it is written as a cabinet, but the more common term that is used is a disk shelf. A disk shelf is used to connect multiple hard disks into the common system, and that's why you can store. Now, the shelves that store the SSDs or hard disks, or the chassis that store the SSDs or hard disks, are separate. But the intelligent component that actually makes data being written simultaneously to these hundreds of drives together, and data being read from these hundreds of drives together, is done by this another component within a storage system called as a storage controller. Okay. So what's exactly a storage controller? So a storage controller, you can say, is like a large single purpose server which has got its own high performance CPUs, it has got its own high performance memory, it has got its own ways of connecting to these shelves and hard disks using these protocols that we learned earlier, SAS or SATA or FCP. Okay, basically nothing but SCSI protocols. Okay, and that software which I was telling earlier, storage software, that storage software is actually sitting on this controller. They are not sitting on these drives. Okay, so this storage controller hardware and the software that is running inside it, they have all the mechanisms, all the algorithms that are used to simultaneously monitor, control, read, and write data into hundreds of hard disks together. Okay, so that's how a storage system is formed. So basically, a storage system for has three major components. One is a storage controller, second is a disk shelf, and third, the disks themselves, the hard disks themselves, either the hard disk or the SSDs. Okay, it is called drive enclosure, it is called disk shelf, it is called disk cabinet. All these mean the same thing. Okay, nothing but a shelf which allows you to power and run SSDs and hard disks. Simple. Okay, but all these SSDs and hard disk individually do not mean anything, but when they are connected together, all of them can be controlled by this storage controller. This is a specialized hardware which has got specialized software in it. Okay, and whose single purpose is to read and write data into these hard disks. Okay, any questions? Yes, the last point is very important. How uh, how we ensure redundancy, or how we ensure that even if there is some kind of a failure, how the data in the drives are getting accessed all the time. So yesterday we heard a concept called disaster recovery, and today we are listening to a new term called redundancy. Okay, both are two different things. Very simple example of redundancy I can give is, in your family car you'll have a spare tire, isn't it? What is that spare tire used for? If any of the four tires are getting punctured, you can replace the spare tire you can replace the punctured tire with the spare tire. Okay, but what if more than one tire gets punctured? You don't have an option, right? So you only have something called as n plus 1 redundancy. Irrespective of the number of tires that are there in your vehicle, you have only one spare. Okay, so that's called n plus 1 redundancy. In storage systems, with respect to the storage controller, also you have n plus 1 redundancy. Okay, what does that mean? We actually have two storage controllers in any storage system. Okay, so that even if one storage controller fails, the other surviving storage controller is able to cater to the data requests. Okay, now ideally this should happen automatically without any loss in performance, but that is not always the case. All right, depending upon the architecture of the storage hardware and the storage software capabilities, this may happen seamlessly or it needs manual intervention. That we will learn later. Okay, so each and every hard disk will get simultaneously connected to multiple storage controllers in the same system. Okay. All right, so we will pause here a little bit and check any questions. Anand, okay, you have a question. Data sheet or specification sheet, both are same. More or less, they are the same, Anand. Um, some vendors call it data sheet, some call it specification sheet. Now, if you want to go into little bit more detail, um, in a data sheet, some features and functionalities are also mentioned. Okay, like what you can do with it. Like when you go and see an SSD cards, data sheet, they'll say, oh, you can store videos, you can store, audio, high performance, directly store from camera to SD card. So those kind of things will be written. But in a specification sheet, those use cases, usages are not written. Okay, only technical details with respect to the dimension, the weight, the certification, the performance details, the interfaces. Okay, who is the manufacturer, country of origin, okay, what are the various subcomponents. Only these technical details are mentioned inside the specification sheet. Okay, clear,
Okay, sir.
Anand?
Thank you.
Yeah, okay. Prakash, you have a question. What if some memory unit damages but not the controller? How do we retrieve or access data from that? Oh, excellent question. So, uh, let me reiterate Prakash's question so that all of us understand what he's asking. We understood that a storage controller, okay, has its own CPU, okay, which is nothing but processors, has its own memory, and has its own mechanism to connect to the hard disks. Okay, multiple hundreds of hard disks, right? Now we know what is the role of a memory, right? Memory is nothing but RAM, random access memory. Now, what is the characteristic of RAM or random access memory? That whenever there is no power, there is no data in a RAM. Okay, power loss, data loss. Okay, very simple. And hence, RAM is called volatile memory. Okay, but what effectively is a RAM? It's the same stuff. It's all transistors only again, which are storing a charge. And hence, these are also susceptible to failure. Even a RAM can fail. Correct. So what happens if the RAM inside a storage controller is failing? Because storage controller is a very critical component. All the important data like your financial transactions, okay, all your health transactions are all being written and being handled through the RAM of the storage and going into the hard disk and the SSDs, right, in the backend, right? So Prakash's question is, what if while the storage controller is working and while it is, serving data, there is a damage of the RAM that is placed inside the storage controller unit. Okay. And what are the mechanisms in place which can handle such failures so that even if such a component fails, there is no impact to the data operations or the operations of the entire storage system. You should, or the user or the workload or the server should still be able to do reads and writes to the storage system over the network. Okay. So the first thing you need to understand, Prakash, and all of you boys and girls, is that the reason you have two storage controllers is for redundancy, so that even if one storage controller fails, the other one can do all the operations. Which means whatever this storage controller is doing and knowing, this controller also needs to have and know. So there is a high speed interconnect between the two storage controllers in the backend. Okay, it's called controller interconnect. Sometimes it's called cluster interconnect. Okay, and these sometimes interconnects are through high speed cables in the back of the controller. Okay, multiple cables running, or sometimes the chassis or the shelf in which the storage controllers are housed or placed, there will be a very high connection, high speed connection on a circuit board connecting both these two controllers. Okay, and it is through this high speed connectivity between the two controllers is where data transfer happens between the two controllers. Okay, And what data gets transferred? Whatever data, new data is getting written to controller 1 is immediately within a nanosecond is getting written to the memory of controller 2 also. Same way, whatever data is getting into the RAM of controller 2 within nanoseconds, it is getting written to the memory of controller 1 also. So both these controllers are like active controllers. They are peers to each other. Nobody is higher, nobody is lower. Okay, both are equal to each other. This also can do complete serving of read and write operations. This also can do complete serving of read and write operations. Okay, and just to handle any potential RAM failure inside these controllers, this kind of a high speed interconnectivity is there between the two controllers, either through external cables or through internal connectivity mechanisms, which will allow whatever data is written to the RAM of controller 1 will automatically get written to the RAM of controller 2 and vice versa, so that even if the RAM on one controller fails, till such time that it gets replaced manually, this RAM in controller 2 will be holding that data and will help in read write access. Okay, clear, Prakash and boys and girls, on how this failure is handled? Prakash, clear? Okay, cool. So, stressing upon this point, somebody has to replace that RAM manually. Okay, and hence this data center engineer job can never be replaced by AI. Okay, AI cannot do RAM replacement, AI cannot do hard disk replacement, AI cannot go and do all this interconnectivity between various data center components. Okay, so that is the reason why if you learn data center technologies like these, you can be rest assured that your job or your role is going to exist for a very long period of time. It is not going to be eaten up by AI anytime soon. Okay, so today we will pause here. What I would want you all to do is whatever research you have done, okay, for the yesterday's class, the learning activities, I request you to kindly post it in the WhatsApp group. Okay, create a small PDF document of all the three questions. So learning activity 1, you put your name, okay, on top. No need to mention any mobile number or email ID. You put your name on top and you mention the first learning activities that was given to you and what is your response to it. Similarly, the second question and what is your response to it. Third question, what is your response? And today also, I gave you another learning activity. Find out who are the top 10 SSD manufacturers in the world. Identify 3 SSD models and download their specification sheet. Similarly, identify top 10 HDD manufacturers in the world. Identify 3 models of HDDs and download their specification sheets. Okay. Any questions until now? Great. Okay. So thank you, boys and girls, for your time today. Hope this training is going well for you, and we will meet again tomorrow. Okay. And tomorrow is a very important day for me. I'll tell you why. So please make sure you join tomorrow's call. Okay. Bye. Have a good day.